Right, hello again. Let's get into this. So calculate the volume of aluminium in Owen's cycle frame, and you're given this list of densities here. So the formula we're going to use is density equals mass over volume, and we're just going to input the values we're given essentially. So we're told it's made of aluminium, so the density is 2.7. So we now know that 2.7 equals 9450 divided by V. And this is a reciprocal equation, and it's well known that you can just swap these around. So V equals 9450 divided by 2.7. So putting this into my calculator, 9450 divided by 2.7. I get it to be 3,500. So the unit of the density was grams per centimeter cubed. We used grams, so our answer is going to be in centimeters cubed anyway, so no harm done there. To get the mark here, you need to state this formula to get full marks. Same with this next one here. So Bethan has a cycle frame that is identical to Owen's cycle frame. What that implies is that it's the same volume, so it occupies the same space. So the volume for this one is 3,500. You would get the ECF mark if you carried on your answer. If your answer for this was wrong and you carried it on down here, you would still get full marks for this, assuming you did it correctly. However, her cycle frame is made from carbon fiber. So carbon fiber, the density is 1.6. So again, we use the exact same formula. Density equals mass over volume, and this time we want the mass. So the density being 1.6, so 1.6 equals mass divided by the volume of 3,500. So now timesing both sides by 3,500, we have that m is equal to 1.6 times by 3,500. And again, putting this into my calculator, it's 5,600 grams, like so. And again, to get this mark, you would need to state the formula you're using. Question 6 here is kind of an odd one in truth. So this bit pi here is kind of peculiar. So first of all, you need to notice is this is in bold. It is drawn to scale. So what essentially this is saying is the ratio of the height to the second platform and to the top would be the same. So if you get your ruler and you measure vertically upwards, you will get this to be about 5.9 centimeters-ish. And you should get this one to be about 2 centimeters-ish. Now, the key part of this is you are allowed to estimate. So estimating means we can alter the numbers slightly to make them a bit more usable. So 5.9 is very close to 6, which is much nicer to use, because that would mean that this is 2 out of 6. So it's 1/3 of the total height. So given that the second level 2 viewing platform is 1/3 of the height, and we're told that it's 324 meters tall, 324 divided by 3, that would be 108. So the second viewing platform is, in real life, 108 meters high. But you have to understand that that is vertical height. So it is very tempting to just say, oh, it's roughly 150. That's not technically true. So 108 meters, you need to kind of visualize how that would work. So the average human is about 1.5 meters tall. So a meter is actually quite a big unit. So, and that's another thing as well, it doesn't go vertically upwards, it's a staircase. So if you imagine a meter in your head, you can get roughly between 5 to 6 steps in, I would say 1, 2, 3, 4, 5, 6. Like so, you can get roughly 6 steps in. So what this means is that it's, for every meter, there's about 6 steps, but we'll call it 6. So 108 meters times by 6, so it's going to be 648, which is around about 650. So that's a reasonable estimate, I would say. And then I believe part 6 has a part B. That's quite a nice part B, actually. So let me just make sure this is in frame. So yeah, find the angle of elevation. So the angle of elevation is simply from the observer's point here, what's the angle that you're looking up to see the top of the Eiffel Tower from 800 meters away. So what is this angle here? And this is quite a nice one. It's very, very standard trigonometry. So it's 324, 800. The key to me that this is trigonometry is that you're given 2 lengths and you're asked to find an angle. So the only way to find that is through trigonometry. So this is going to be tan, I believe. So we've got the opposite to the angle. This is the hypotenuse, so this must be the adjacent. So we've got opposite and adjacent, so it is tan. So tan of the angle is equal to opposite over adjacent. In this case, tan of theta is equal to 324 over 800. So therefore, theta equals tan inverse of 324 over 800. And then if I sub this into my calculator, I'll get 22. I believe it's 0.5, but let me check. 324 divided by 800. 0.05, let's say, so 22.05 degrees, and you'd be well within your rights to call that 22 degrees.